A particle of mass 10 kilograms is projected at 10 meters per second up a rough plane inclined at 30 degrees to the horizontal, starting at point A. The coefficient of friction between the particle and the plane is 0.2. What's the speed of the particle when it returns to A? So what we have is a particle on the plane here, and what it's going to do is go up, stop, and then it will slide back, and we want to know the speed when it gets back. So let's look at the situation when it's on the way up. So probably should draw it a bit further up the plane here. So we've got 10g, and clearly that's going to resolve into 10g cos 30 this way and 10g sine 30 this way. Once we've got that, we can obviously ignore that. There'll be a reaction force as well, so there'll be a normal reaction here, and of course there'll be the frictional force, which if we're travelling upwards, the frictional force is going to oppose the motion. So if we look at the resultant, obviously n is equal to this, so we're going to have n is equal to 10g cos 30, and that's not going to change whether we're going up or down. So if we look at the resultant force, it's all parallel to the slope, and it's going to be 10g sine 30, add the friction, and the friction is going to be 0.2 times the normal reaction, which is 10g cos 30. So that's going to be the resultant force. So that's going to be equal to the mass times the acceleration. So 10g sine 30 plus 0.2 times 10g cos 30 is going to be equal to 10a. And obviously we could cancel the 10s there, and so we can get a. So our a here is going to be 9.8 times sine 30, add 0.2 times 9.8 times cos 30, and that's 6.597 meters per second squared. So what we can do now is work out how far up the plane it goes. Remember, that's going to be slowing us down, so it's negative 6.597, and that's going to be 0 when it gets as high as it goes. The initial was 10, and we want to know this one. So we've got v squared equals u squared plus 2as. So 0 is equal to 100, and take away that last answer times 2, negative 13.19 for 8s. So the distance travelled up is going to be 100 divided by that last answer, 7.5787. Sorry, 7.5787. So that's how far up it goes. Now, think about on the way down, all that's going to happen, so if we just do a quick down diagram, I won't put everything onto this diagram though, all that's going to happen is the 10g sine 30 would act this way, but now the friction would go that way. And of course the friction is just going to be mu times n again. So the resultant force here is going to be 10g sine 30, but this time it's going to be take away 0.2 times 10g cos 30, because they're now acting in opposite directions. So if we say that that's equal to 10a, as we did before, so 10g sine 30 take away 0.2 times 10g cos 30, that's going to be equal to 10a, and once again we can cancel those 10s through, and so we can work out the acceleration for this part of the motion. And so that is going to be 9.8 times sine 30 take away 0.2 times 9.8 times cos 30. And that's 3.2026. Just check that. 3.2026. Yep. Okay, let's make some room for us to work with this over here, because we're now on the way down and we need to do the same sort of calculation we did over here. So we've got suvat, because it's constant acceleration. The acceleration this time is going to be speeding up, so 3.2026 is positive, and v is what we're very much interested in finding. On the way down, of course, it starts from rest. It went up the slope, it stopped, and then it's coming back down from rest. And the distance is, of course, 7.5787 meters. So v squared equals u squared plus 2as. So v squared is going to be 0 plus 2 times 3.2026 times 7.5787. So just need to calculate that. So we have 2 times 3.2026 times 7.5787. That's 48.543. And so v is just going to be the square root of that answer. And so it returns back at 6.97 meters per second, correct to 2 decimal places. And so working against the friction on the way up and on the way down has lost us some speed and therefore kinetic energy. Some of our energy has been used up in working against friction.